this video, we are going to talk about parallel combination of resistors. Last time we had a discussion about, not discussion actually, I had explained you the series combination of resistors. Series combination means when we connect the resistors end to end. This was the series combination. Suppose there are three resistances and we had joined them from end to end. This is called a series combination of resistors. Now today we will talk about the parallel combination of resistance. When we have connected three resistors parallel to each other. Suppose this is our R1, R2 and this is our R3. In this case, it's very well clear to you. If I put a battery across these ends, only the battery, and suppose there is a plug key and I put it on, this is a positive end, this is a negative end, and if I put the battery across here, this is R1, this R1, positive end, negative end, ammeter. Suppose this is our ammeter. In this case, we had seen that the current anywhere in the circuit is same throughout the circuit. In case of series combination, the current throughout the circuit was same. But in the parallel combination, you will see from the battery, the current starts flowing. And now the path of the current has been divided into three parts. This is the first part, this second part and third part. The path of the current is divided into three parts. Current may, see, this is the way. Here the path of the current is divided into three. Here the path of the current is not divided. Current is flowing from here, from here, from here, from here, and then coming back to the battery. But in case of parallel combination, the path of the current is divided. That is why it is called our parallel combination. One very easy thing to remember this parallel combination is that when the path of the current will be divided, whether 2, 3, 4, 5 number of paths, more than one path if the current is going to take to complete the whole circuit, that means it is in parallel combination. If it is moving through the same circuit, then it is series combination. In this case, the path of the current is being divided into three. And that is why these three resistors, there are three resistors and I have come to know that this is a parallel combination. In series, the three resistors were connected end to end. But here these are not connected end to end. These are connected separately. So let us start our discussion about parallel combination of resistors. Children, last time I had told you that series combination, derivation for series combination or parallel combination. It's really an important question from your examination point of view. I mean to say your board exam. It's really an important topic. In the exam, you may be asked to get a derivation for the combination of resistors when they are connected in series or when they are connected in parallel. Let's start. Suppose I have taken a circuit here. This is a 6-volt battery, 1.5 volt each, 6-volt battery. Alright, the current starts flowing. I have connected an ammeter here. Across three resistors, parallel to these three resistors, I have connected a voltmeter. Then I have a plug key. It's a very simple circuit comprising of only of a battery, an ammeter, voltmeter, three resistors and a plug key. In this case, when I have made the circuit like this and I have to note down the reading in the ammeter and voltmeter, I find that the reading in the voltmeter, in this voltmeter, the reading is V, and in case of ammeter, the reading is A. Now what will I do? When we connect connected the voltmeter separately across each resistor also, the value of V is same. Suppose I have removed the voltmeter from here. I have connected the voltmeter only across resistor 1. This is a positive and negative and voltmeter. I will note down the value of V is same as it was earlier when I had connected the resistor here. Now voltmeter here. Now I remove the voltmeter from this. I am going to connect it here across the second resistor. I will note down again the value of voltmeter is again V. Now only across this third resistor, if I join it only across third resistor, this is if I join only across third resistor, I will note down again the value in the voltmeter is V. And you all know that voltmeter is always connected parallel to the resistor or between 2 points whose potential difference we want to measure. These are the 2 points whose potential difference we want to measure here. So now I have put this voltmeter across resistor 3. I will note down the value of again V is same. So that means the value of V in case of parallel combination remains same. It does not change. But it was opposite in case of series combination. Now earlier I had the ammeter here. Now I will remove the ammeter from here. I want to place the ammeter here across resistor 1. I will note down the reading in ammeter is across resistor R1 through resistor R1. The value in ammeter is I1. When I have connected the ammeter through resistor R1, the value in ammeter was I1. Now I removed the ammeter from this combination. Now I will put it across resistance 2. Then again I will note down across through resistor 2, the current flowing or the value in ammeter is I2. Now let me again remove this from here. Now I am going to join the ammeter with resistor 3. Ammeter. Again I will note down the value. When I connect it with resistance 3, I will note down through R3 the amount of current flowing is I3. And now let me remove again from here. Now it is the earlier combination which it was the previous combination which I had in the beginning. Now I will note down again the value which I had got in this combination, that is I is equal to I1, I2 and I3. I is equals to I1 plus I2 plus I3. That means in parallel combination the current gets divided. It is not same throughout the circuit. That is why children, we have in our household we have parallel combination, not series, because to operate a fan or a switch we need different amounts of current. Can we use the same amount of current to run a fan or a washing machine? Can we use the same amount of current to switch on and you can say oven as well as a tube? It is not same. We need different amounts of current to run the different appliances. That is why our household circuit is in parallel combination, not in series. Next topic, we'll discuss about the advantages of parallel combination over series. Now let us see. When I've got the value of current through R1 was I1, through R2 was I2, and through R3 was I3. And also we had noticed the value of I here is equal to I1 plus I2 plus I3. Now applying Ohm's law in equation 1. If I apply, this is our equation 1. This is my equation 1. If I apply Ohm's law, we know Ohm's law, V is equals to IR, or I is equals to V upon R. Now if I apply Ohm's law here, I got I's value V upon R. I1 is equals to V upon R1. I2 is equals to V upon R2. I3 is equals to V upon R3. Why we have taken V here same? Because we had seen in the voltmeter, reading of the voltmeter, anywhere in the circuit across three, not circuit, anywhere across these three resistors, if we put it separately, then also the reading was V. If I have joined these three resistances in parallel and then also I have noted down the reading, then also the reading in the voltmeter was V only. So that is why here V is same. Let me take the V common. 1 upon R is equals to V, again I have taken here common, 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now let us cancel V and V. I have got 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. It means reciprocal of equivalent resistance. This is the reciprocal of equivalent resistance of a group of resistances joined in parallel. It is a group of, because there are three resistances, that is why it is called a group of resistances joined in parallel, as these three are joined in parallel, is equal to, this is equal to the sum of the reciprocals of the individual resistances. Reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. That's all, children, about the parallel combination of resistances. Next, advantages of parallel combination over series we will do in the next video. Till that, stay indoors, stay safe.